In this video, I'm going to be talking about synthesis of esters and their mechanisms. The first thing I would like to talk about is what esters are. So esters would be an organic compound that has a carbonyl compound and also an OR group attached to the carbon bearing the double bond oxygen. Now, what is R? R groups are just carbon chains. It could be one carbon, it could be as many carbon as possible. And example would be CH3, C double bond O, and OCH3. So this is a typical ester with just a methyl group attached to the O. Instead of R, you have CH3, okay? Now, how is this esters formed? Esters are formed between the reaction of a carboxylic acid and an alcohol. So when these two react in the presence of an acid catalyst, it forms an ester. And this reaction is known as Fischer esterification reaction. So the simplest way to find your product, if you are asked to draw the product for this reaction, would be to combine the hydroxy group of the carboxylic acid with the hydrogen of the alcohol. Now, when you combine these two, they are going to leave as water molecule. So the OR will then replace the OH and attach itself to the carbon bearing the double bond oxygen, forming this product, which is now an ester. So you have the arrow connected to the C double bond O and now the new OR, which was attached. So this is how you form an ester using carboxylic acid and alcohol in the presence of an acid. Okay, so for this other example, we were asked to give the product of this reaction. Now we're still going to make use of the shortcut since we have not been asked to write the mechanism. So we combine the OH of the carboxylic acid and the hydrogen of the alcohol, remove those as water molecule, and then draw out the starting material like that. Okay, and then the oxygen from the alcohol group would combine with all the other things attached to it, and that is the product of that reaction. Okay, so now let's look at the mechanism. So if we are to write the mechanism, because this is catalyzed by an acid, the first step would be protonation. So we're going to use the lone pair on this to pick up hydrogen from that acid. So we have this, okay? So we're picking up the hydrogen from the acid. So when this happens, the first part would be a protonated while the double bond is now attached to the hydrogen. And this oxygen will be having a positive charge on it because of the extra bond that it's having. Now from here, the next step would then be that this alcohol would then attack. So this alcohol here would then attack the carbonyl compound. So you have the lone pair on the oxygen attacking the carbonyl compound. Now, so when it attacks here, this bond will break, okay? And so you're going to have this OH, okay? The bond has broken, so you just have a single bond there. And all of this is going to attach with the oxygen, and you have hydrogen on this side, and you have this other one attached to the oxygen. Now, this is going to have a positive sign on it, okay? And because of that, we're going to do deprotonation using another molecule of the alcohol. So this is going to deprotonate this, and this bond here will break. So from here, we then have OH here, another OH down here, and you have this oxygen with the extra carbon. Now, oxygen has been deprotonated, so we don't have hydrogen on it anymore. Now, here, we need to form an ester, right? So we need a double bond to form back, and then something has to go. We're not going to be removing this part of the reaction because we just added it, and that is what will give us the ester we're looking for. So we need to remove this OH that was originally there. Remember, we have to replace the OH or substitute the OH with the OR group. So now we need to remove this. And in order to remove this, we need to make this a beta leaving group. So what this is going to be doing is to pick up the extra hydrogen we pick here. Okay. So this extra hydrogen is going to take it away. So I'm going to wipe this out so you can see what I mean. Okay. So this give the extra hydrogen it just took from this one here. It gives it back to this guy. So at this point, you have a beta leaving group attached on this compound. So I have OH2 plus, which is a beta leaving group than any of the species there. So at this point, the lone pair on this oxygen is going to come back the double bond, and as it does that, this bond will be kicked off. Okay. Therefore, we then have from here, we're going to get this. The double bond has formed back, but there's hydrogen on this oxygen. You have a positive charge, and you have this. This was removed, right? So you only have this now left. You have this for this carbon. So now that water that was just kicked off is going to come back here and pick this hydrogen away. So when it does that, our final product would then be this. So this is the final product.